Yes, I only did 2.
Okay, that's fine. Yeah, no worries.
I mean, since that results, I mean, yeah, it different every time for sure. But then, yeah, it's still like almost same.
Yeah.
Yeah, you understand. But it's really cool to get familiar with the Colab, Google Colab. Really useful, I guess.
It is. Hello, Carlos.
Hi, Sang-Young.
I saw your email. I checked the images. It looks pretty cool.
Thank you. Yeah, I liked. I enjoy doing that. Yeah, it was just a simple question. It's just it looks like it was not grabbing the whole data set. So I'm not sure about that.
So if you're like you get me this number of the what is it? Number of the data sets or the size of the data set.
Right.
How big was it? Like
So there my email. 1 second.
okay, I'm on your email.
So I remember I wrote it at the end. Oh, it's just that I wrote it in the.
Yeah, I know. Yeah, I see it. I see it. Yeah.
But so whenever I used all the images, the result was like very. It had a lot of variety. But
yeah,
I used like less, like a size, like half of the size. Then it looked like it only grabbed like half of the data set.
Okay, I see what you mean. Yeah, because the TSNEO is trying to bring the a similar data sets and then make that as a you know the segregated information. So that's why it's happening. So if you use like let's say a smaller grid size, it is kind of inevitable to have like a little bit of a more of a homogeneous condition than heterogeneous condition.
Right.
Does that make sense?
Right. Yeah, I liked more the ones in which I used, the full grid size.
Yeah. I like that better too. Yeah, it looks pretty cool. If you guys, so like for the archiving purposes, I want to collect all of these images if you have created one, so that I can keep it as my teaching portfolio. If you guys are comfortable sharing that with me, you can put those images in the Google folder, a Google Drive folder. I made the folder called the work from the participants, and then if you put the examples of these TSNE images on that folder, I would compose that and then post it on my personal website that I'm working on right now, and also other things. If you're okay with it. Is everyone here? Maybe.
Yep.
Okay. How's it going, Jechang?
It's going great. Yes, last night I also tried to make that images by using auto tool. And I noticed that when it comes to cutting the images, cutting exactly that elevation correctly might be one of the most important things, because when I trimmed the images last night, I just include some kind of topo and some trees or some kind of that landscape features, so that kind of blurred all the images here. But
yeah, it's actually quite of a, let's say, once you make your code, all the most, let's say, the writing of code is actually 10% of the work. 90% of your work is actually designing the data set, because depends on how you design the data set, your outcome will be heavily biased by that data set, right? So it's like very different from the traditional workflow, where you spend most of the time like designing the final outcome. But here spending most of the time prepping for that the final result. So it's very different sort of workflow, of course. And as an individual person, you have some limitation on how much of a data prep that you can do or you want to do. So that's yeah, that's a little bit of a question. So before the class starts, I wanted to share this cool cat picture that I made yesterday when the Sarita was asking for the help for how to make the data set. So you can see like it recognized like these the section with the what is it? I don't know what is this, what this is called, but then the the fur that's come out, and then the most of the like feet are here, most of the ears on the top, most of the eyes are here. So you see that it works pretty well as an image segmentation. It's with the facade, it's a little bit hard to tell sometimes, but then for something like a animal or some organism that has a very specific characteristics, you can segment the part of their what is it, like features into quite let's say quite accurately. This is of course a very quick run, so if more iteration that you put in, this result will be more accurate. And instead of segmenting cat images, you can put a bunch of different types of cat images as a whole image, and then you can compare which cat resembles another cat, and then what kind of a cats, for example, like long fur cat and then short fur cat, and there are like this bunch of different kinds of a cat or dog, and then it will be also interesting to see how if a TSNE can compare the cat to dog. So there are infinite opportunities that you can explore through this method. I know that Lara, you create a few images, and then Carlos, you also create a bunch of images, and then Jaechang, you also mentioned that you created some images. Before we go into the tutorial, do you guys want to share that with me or with the class, so that
it's the same? It's like the same facade.
it's the same data set.
Yeah, exactly. All right.
Okay.
Maybe I can share my screen real quick.
Yeah.
You mean share it on the chat?
No, you can share
chat?
your screen. You can share your screen.
Okay.
By one, two. Yeah.
Can you see the screen here?
Yeah. Okay.
So yeah,
Nice.
I can see kind of the relationship with these kind of pattern here. I mean, I select one just lot area block of the city, but as you know, as you see here, let's see, there's some people, trees. Yeah, here we go. I mean, cleaning the data set might be one of the most important thing to have that.
Yeah.
So yeah, that's mine.
But it really looks pretty cool. I can see how one thing relates to another thing, and then there are some interesting happening like over here, like alignment, misalignment, and that sort of stuff. So one thing that so this is something that we're gonna cover today, shortly after you guys present your work. But you can actually change how much of an overlap there could be between your one cell to another cell. So you can intentionally make some sort of a misalignment among your data sets, so that you can actually create a little more crazy images. If that's something that you desire, that you can create that. For instance, on this case, like there is this like misalignment thing is starting to look pretty interesting, and I mean, of course, this is construction purposes. For construction purposes, it's not ideal condition where you have a window ending on top on that kind of stuff. But then, as an compositional tool, I think it is quite strong. So yeah, good job.
Thanks.
Yeah.
Yep.
And did you guys test with the different perplexity and how that creates a difference?
Actually, I did.
Okay.
Here, or maybe I can keep share my screen. Can you also see my this my folder? My
Yeah.
Okay, cool. So this, okay, here we go. So this is the perplexity 10, and this is 50, first trier, second trier, third trier, fourth trier, and this is perplexity 70.
Okay.
And this is perplexity 100.
Yeah.
This is perplexity 200.
Okay. Yeah. You see, like at the 200, it becomes like not actually efficient. At beyond a certain point, it segregation form doesn't look that segregated for the human eye. So there is like a certain limit to the perplexity, that the how things are coming together and then going away. So I wanted you guys to play with this sort of values, and iteration wise, it doesn't really change that much. Like of course, if you do iteration 10 and then if you do iteration 10,000, that will create differences. But as long as you're above 1,000 and 5,000, it should follow the same.
Yeah, I think 50. I feel like 50 gives us kind of the best outcome. I'm not saying that. I'm not. I mean, best sounds weird, but yeah, I mean, I can figure that out. Kind of grouping kind of boundary. Here.
And based on what kind of result that you wanna use, it's also useful to use a different types of facade condition. Like this one is super nice actually, because there is this very similar types of condition here. I can already see this as a some sort of building. It's pretty cool.
Cool.
Okay. Anyone else?
I could share quickly too. 1 second. So I used some different base images, let's say, to start the segmentation, and I was interested in repetition. So I actually had some images from Hong Kong and just different type of orthographic views for facades, and I was interested in repetition and also but also the scale, and maybe combining the two of them. So like this with something like this, how could that tie? And then I did wanted to make it like really colorful. So the results are more or less these here.
Yeah, look at that.
So these ones at 128 size. This is the one of my favorites. And it's using the whole data set as I was telling you before. But when I started to change it to like half of the size, you can see in these images here, it's like it's not grabbing all of the images, and then I was losing some of the some of the data set parts that I liked. Yeah, I played with different perplexity levels and sizes. Then I didn't know, I haven't actually, I don't know how the Houdini workflow was going to respond to this. So I like a lot when when we produce like really dense images.
Yeah.
So I don't know. I guess I'll have to test which one work better.
Yeah.
Then these ones here more or less start to combine the more domestic scale with the more urban high density scale over here.
Yeah. It's super nice. Super nice. Yeah, like as Carlo did, the possibility here is that you can actually go to Photoshop and then do gradients and then apply filters, colors, whatever, and you can even pixelate your images so that it becomes some sort of a more of a tilized, like pixelated art thing. So there is an infinite opportunity that's that you can use this tool for. I think this is super compelling image. It will create very interesting image, very interesting 3D tessellation, because there is actually quite a lot of homogeneity within the like, let's say, formal quality. Like a lot of your buildings has a like more of a verticality, and then the grid thing. If you have that, I think that, so like today we're going to actually do Houdini and the Blender to create the 3D tessellation. So I hope that you guys got my email an hour ago about installing the Blender. So I think for you, Carlos, you can use a Blender to create more of a larger facade scale. Houdini is more better for the more precise control of each like facade, like a layout or smaller scale. Like for example, if you want to harvest this area and then you want to, let's say, develop this area with much high detail, Houdini is very useful. But then in terms of overall images, I think you can actually use a Blender to create this entire thing as some sort of a huge scale, a super studio kind of a aesthetic. You know?
Right.
Yeah. It'll be great.
Sure.
It'll be great. I'm excited.
Great. Thank you.
Yeah. Anyone else who want to share? Okay. So if there is nobody who wants to share, let me share my screen, and I'm going to explain what we're going to do today. So here, we just did this review of the TSNE result. Was there any problem when you were trying to run the Google Colab? I know that we were doing a lot of troubleshooting yesterday, but then if among the people who was more quiet yesterday, if you guys tried it yesterday and earlier today, and then something couldn't work out, I can spend some time on troubleshooting. Was there anyone else who needed the help for the Google Colab or the code part? Any clarification from the yesterday? Okay. Then we'll jump into the advanced control of a TSNE. It's not really it's not really anything special, but then we can design pretty like interesting images with a few let's say parameter change for the grid setup. Okay, so I'm going to jump into this. I want you guys to access the TSNE Grid Master folder, and then open the TSNE Grid py. And once you double click this, you would have this the screen. But what you want to do is open with the text editor. Okay. And here now we have this nicely laid out the code here using the Google's notebook, where the place that we want to get to is this save TSNE grid. This is where you're basically drawing the image on top of the grid and then set up the grid and all that kind of stuff. So here you see this grid and numpd stack. This is the command for making the grid. Right now there is no overlap between one image to another image, so it's more or less very cookie cutter aesthetic of a suburban. But we can make this a little bit more interesting by changing this number to, for example, 0.75, 0.75. Then it will overlap 25% like this. So if there, it just from what I saw from the Jechang's images, I think that it would create very interesting the facade design where there is some sort of misalignment or alignment that creates some sort of a rhythmical, aesthetic. And you can, of course, can do a much smaller number. You can. I would not recommend doing it in the uneven kind of a scale like this, but you can try. Let's see what this would make for me. So after you change this, you save this to the drive, and I will open the my Google Colab, the TSNE. This one. Okay, so we're back to the Google Colab here. I'm going to check the runtime GPU. I'm going to, because I have a high RAM, I'm going to save it as a high RAM, and I'm going to connect. I'm going to change a few things here. Just to get the faster result, I'm going to change this to 10. And I'm going to change this to overlap. When you're working with machines, you always have to wait. That's the worst part. You can't just do it. And
Right. Could you, in the meanwhile, could you highlight the line that you changed in the script?
yeah, of course. Here.
Oh, 91.
Yeah.
Let's see. Yeah, thank you.
Yeah. I'm just gonna leave it here in case there's anyone who wants.
Tanya, I have a quick question. Can I share my screen real quick?
Yeah, no problem.
So I just saved this changes, and I just noticed that there's a 2 TSD grid file. Is it okay?
Why did that happen?
I'm not sure. So yeah, I just changed this code here, and then I saved it.
Yeah.
And I just noticed that there's 2.
Okay. There's a solution to that. Can you go to the TSN grid PY again?
Gotcha.
And then go here. Click
Okay.
click the title, and then change it with something that you can recognize. Like for example, here, like overlap.
Okay. Overlap under dash. Okay. Maybe something like that.
Okay. Yeah. And save that now. Yeah. Okay. Now you know that this is a overlap TSN. So go to the that again, and then now you have a stop that, and then you should change this name, or alternatively can you actually make another tab for the code? Yeah, and then the copy what you have here. Yeah, yeah, and change this to overlap. Here overlap.
Right, gotcha.
Yeah.
Okay, and then size 10.
Yeah.
Okay, okay, I can just run this one here.
Oh, wait. So you're using image 520, 512?
Yes.
And then resolution is your resolution is 128. So you should change it to 512.
512 as well. Okay.
Yeah.
All right. Got it. So I gotta run this one. Okay. Okay, thank you.
Yeah. If anyone gets the result, let me know. My thing's still running.
I have actually a question.
Yeah.
It's more about the process of how you learned the algorithm. So I have some experience in Python.
Yeah.
But then when I look at this code, it's huge. Like it's not that easy. So I tried to dig in, but I don't know. Can you just like elaborate on that? How the process went? How much time did it take? Like
for me personally to learn the coding.
Yeah, like the coding part and the algorithm itself, how it works and.
Okay. So before coming to architecture technology program, which is a 1-year postgraduate program at SCIAR, I didn't have much experience in coding. I knew how to do MATLAB, which is some variation of a C# for the scientists, actually. I used that before, but then not extensively. I was just doing some math over there. And then, I learned most of the Python, JavaScript, and machine learning, and all these tools within this year. We just had to learn it because our studio was all about that sort of the coding, and then the coordinator for the program is I don't know if you guys know Michael Casey Ram, but then he's one of the pioneer in the this sort of computational design field, and then now he's the coordinator for this program. So he was like basically doing like very intense base camp for us to learn the Java and the Python. And then for me the most helpful thing was that trying to, let's say, not trying to learn all about the Python, but then only the parts that the designers most oftentimes use. So like when you look at the Python, the tutorials, like they will like start with the like array, and then they'll start with the string, int, and like all that kind of stuff. At the end of the day, like if you're like trying to learn some like a pretty complex thing, that's compared to the the introductory stuff, it's like very distant. And then most of designers, we use a float, int, and then sometimes string. That's all you really need. So don't worry too much about the theoretical the concept behind the computational design or the coding. Just get some examples from the designers out there who's doing coding, like using processing sketch or using Unity, for example, to make the form. But the most important part is that actually not your ability to code. What I believe is that you need to think computationally to code well as a designer. Just like Grasshopper Grasshopper, you don't actually code, right? You are using the node to node. But then when you actually, deconstruct those nodes in the Grasshopper, it is all actually written in the C#, C++, Python. It's not really that different. So you need to think about how you're going to approach your let's say you need to have some sort of like a structure in your head already, like what kind of thing that you want to actually design with your code. You need to think about modularly, like what kind of things that can you manipulate. If it's an image based, if it's going to be image based, what can you think about image? It's always consists of a size, pixels, and then also the color values within that pixels, right? And then there will be pixel is considering with the size, and then the color value is 3 values, RGB, which can be vectorized. When you think about the X, Y, Z as a coordinate, and then put the RGB in the X, Y, Z, now you suddenly have some sort of a vector dimension. You can plot your colors of your the images into that 3D space. And then on top of that, you can add another dimension, which is the coordinate of that pixel, if you have an image, right? So like this sort of thinking is necessary. Once you know a few like tools, you can, especially for the processing sketch, once you understand the core structure of how data is made of, it gets easier. For this type of a machine learning stuff, it's a little bit different, because every case is completely different. Like from, let's say, TSNE to StyleGAN is completely different.
Yeah, that's what I meant, because I mean, I did a lot of, like, for instance, Vex, like an EDA.
Yeah.
I did a lot of like forms and things like that, but this is like a whole new thing, like the algorithms of how AI actually works. That's why I was like a bit, ooh, that's not what I did.
I see. So for me, like, I don't completely understand what everything here is working, right? Like if I open our code again here, we're importing all this, the APIs, and then it's impossible for individual to understand what exactly each individual thing is doing as a designer. That is for the computational scientist. Yeah, so don't be too, let's say, nervous about all these like foreign things. You just like I start with this, right? Because this is something that I know that I for sure I'm going to use. Then you're thinking, oh, like, do I need to plot something? Then, oh, I'm going to use this. Oh, do I need like maybe different image library to do some work? And as I mentioned yesterday, like this is like a mathematical tool. These two are mathematical tools. So if I segment these.
Wait, you're not sharing your screen.
Okay, yeah, right. So here, if I segment these into different things. So this is like a math. This is interface, and this is just TensorFlow, and this is plotting, and this is image, and this is TSNE specific, and this is a more complex mess. That is specific view. And about all other than that, all these like very specific things, you just bring it when you need it. And sometimes you have to surf on the internet for like minimum 1 day, like to like few weeks to find like what exactly you need. Of course, there are some going or like get around, like, or the, let's say, like a bypassing this and then write all the codes that you that is necessary for the code to run. But then do you really want to do that, or do you have mathematical ability to do that? I'm not sure. So it's all about really like trying to I'm always on the GitHub trying to steal, whatever other people figured out, and just but they're sharing, they're not like putting that as a private, and then whenever you're using someone else's code from the GitHub, you credit them, and those people who's on the GitHub, they, let's say, make more like a reputation in the community, and then they become this like important figure. And so like don't I use the word stealing, but it's not really stealing. Like you're always accrediting the person, and you're contributing your work later on to the community. It's more of a feel of a community. So that if you go to GitHub, there are so many things that you can learn from. So GitHub is the way to go, but it's not particularly user friendly. But once you get used to it, it's actually quite nice, because here we were downloading stuff from the Google GitHub link, right, on top here, like. So you can link, once you establish your repository, and that you use this a lot, you can put this in your repository and then import that library right into your code anytime you want.
Yes.
Yeah. I heard someone like speak.
Oh yeah, I was just saying that, yeah, that interconnection that you were able to do with TensorFlow through Google Colab, those specific lines like for importing, I mean, that's what I am impressed by and a little bit overwhelmed too. Was that part of the bootcamp that you mentioned that Casey gave you at your program, or is that your personal research?
You mean the Google Colab?
Well, I mean, not Google Colab. I mean, the part of the Python script in which you are actually bringing all the TensorFlow.
I mean, like, of course, like he didn't cover the TS he helped me here and there, but then he taught us how to use it, how to use like this PyCharm environment, and how to use the Google Colab, how to use the Anaconda environment and all that. I had to make many adjustments to it, and some library you need to like look for it and then know like vaguely what it does, so that you understand this is doing the correct thing for you. It's really trial and error. It is, of course, a lot of labor to get to that point, but once you figure one like script out that is suited for your purpose, you can do a lot of different things, right? So yeah.
That's great. Thank you.
Okay, let's see what it made.
Can you just write down the name of that coordinator at your university?
Yeah, I will put it in the chat. So, am I recruiting some people for Cyclones? Carlos, you also went to the same program, right?
Yeah, Casey was my instructor as well. I know him very well. I know his work. But I mean, I got out before he was into like too much into artificial intelligence. So, but I follow him. I know what he's doing. So
yeah,
that's what I was interested.
Yeah. Okay. When did you graduate?
2015.
Oh, okay, long time ago. I see.
Oh, Carlos, do you by chance know Helena Megar is IARC?
Helena who?
Helena Megar. No.
I don't think so. No.
Oh, okay. Got it. Yeah. Gotcha.
Okay. Yeah. So here you see this image, right? Now, like these are much smaller than what it is because we overlapped it by the 0.5. But you can Photoshop this black out, right, later on if you want to. You see how like things are overlapped, so that there is a little bit of a more let's say the irregularity introduced. You can test this out and then see what works for you. And if it doesn't work for you, that you don't have to use this. It's just a test. Like I'm showing you, there is some flexibility within the code that we made, so that you can create let's say more enticing image from it. or more variation of a style from one code. There are more possibilities within this grid thing. We can also potentially delete the. You can also set up your grid to delete the black. But you know, like sometimes it's easier to just go to Photoshop and delete the manually, right? So I'm not going to go into that detail. I just wanted to show you guys that this is a possibility. Okay. Yeah. So now we're going to use the Houdini voxelization. Well, I'm going to start the Houdini part. Oh, anyway, did one of you guys the code here finished, or the running on the collab finished? If you guys want to share that image, I would love to see it.
I got it.
Okay, let's see it. Oh, look at that.
So yeah, it's like there's more overlap. Yeah.
Yeah. The color scheme is very like a, you know, the Bofill, the brutalism, the residential guy.
Bofill?
Yeah. Ricardo Bofill.
Oh, Spanish. He's from Spain.
Yeah. It somehow remind me of your image. Somehow remind me of the possibility that it could become his architecture. His stuff is very voxel too.
Yeah. No, that's nice.
Yeah, nice.
All right.
Cool. Okay. So let me start with the Houdini. Okay, I will wait for you guys to open the Houdini. Does everyone have a Houdini? Okay, I'm not like that expert in Houdini. I just know like you know how to do what I did. I was also watching just many tutorials to do this, so I'm not like as that. I'm not that of an expert. So some of you might know better for the just in general like how Houdini works and all that. If you but for the specific purposes of our project, I'm going to cover voxelization of so basically tessellation of 2D from 2D to 3D. Okay, so here we start with the grid first, because our stuff is in grid, right? We have this grid, and it's really up to you how many, let's say, grid that you want. Here we have this grid, and no, actually we don't want this as a grid. We should start with the geometry first, because this geometry node is actually the top of the Houdini node that you can embed all the things. And how Houdini works is that once you make the node, there's also something embedded inside of it. So now we're under a Geo 1. So just for the clarification, I'm going to name this voxel tessellation to the 2, 3D. Okay, so we have this name here, and inside of that, we're going to now make the grid. Grid here. Yes, grid is here, and now it's a 10 by 10, but you probably want more than 10 by 10. But then remember, if your computer is not that strong, you don't want to go too high. For me, for this particular demonstration, I think I'll go to 500 to 500, and this is still very heavy, so you know, be reasonable. So maybe it's too high actually. I'm just going to go 250 here. Yeah, but remember, if your voxel size is like or your grid size is too small, it's not going to catch all the nice details that you have in the images. So if you're in your image, so make sure that you have enough.
Quick question: how did you make that the view as a top view? For now, for me, it's perspective.
I mean, I just move it around. It doesn't really matter.
Okay.
Have you used the Houdini before?
No,
It's
actually, this is my
top
first time.
corner on the screen. It's like
corner.
Yeah. Set view top viewport.
Okay. I'm sorry, guys, but can I share my screen real quick?
Yeah.
No
problem.
Okay. So here, it's weird because I see nothing here. Did I miss something wrong? Did I go something wrong here? I created this here, a geometry first, then create this grid in that geometry. But I did not see any kind of grid here.
Hit F. If you hit F.
Yeah, that will focus to your object.
Yeah, I just hit the F, but it shows the grids top here. 4.2 maybe. No, it's weird.
Let's be dumb here, and then let's close this Houdini, and then start new version. I don't know what kind of a button that you hit before. I see the screen, so sometimes it's just easy to start from the.
Okay, got it. All right, I'm gonna stop sharing the screen. Thank you.
Yeah. And let me know if you still have a problem with the grid setup. Once you start your Houdini again. Here, let's see. Now we have the grid, and under the grid, we're going to connect our like all the geometry nodes here under the grid. It's a good practice to embed the complex code in the subnetwork. So we're going to make a subnetwork that's connected to here, so that you can always like expand and then connect multiple different things to this node to get different results. Once you connect this, I'm going to double click the subnet. But before we do that, I'm going to call this as a voxelizer. That's what the voxelizer. We're in the voxelizer, and as you can see, there is a 4 node here. Depends on where you connect this. So you can have let's say a few different versions of a grid here. So you have a grid 2 here. You can name this as a 500 by 500. Actually, I'm a little bit worried that this will crash during our Zoom call. So I'm actually going to make this as a 64 by 64 and 64 by 64. Maybe that's too small. Yeah. So I have it right now here, 128 by 128. And we're back here. So you can actually have it set up like this. So this is 128 by 128. You can connect it here so that you know that you're using 500 by 500 on the second node. But for now, we are going to use 128 by 128. Okay. So we don't need this output for now. So we're going to delete that. And at the start of the this code, not code, but the node, we're going to just put the null here. Null is just an empty box that you can put anything in, basically. So instead of that output, we now have this null, so that we can just check whenever you're unsure about your outcome. You can just link the this empty box to check your geometry, and you can also use this for the like flattening purposes and all that. So it's quite useful. And we're going to call this in geo. Okay, in geo, because this is a incoming geometry. Yeah, and once we finished doing that, we're going to put the it's called the attribute from map. Attribute from map is something that you can link your texture to. So here, for now, I'm going to actually use something that is quite small scale. I'm just going to bring a single facade image. So I'm bringing this facade clip, image from facade clip. You can use whatever image you want, but then what you want is something of a smaller scale because of Houdini is like, that's a little boring. So maybe we'd pick a better image, something with a pretty good amount of the detail. Okay, let's do that. What's that number? 131 PNG accepted. You see now, like this has much more articulation on the bottom, and there's some this similarity between the top to the bottom. So now we have this. Okay, but because the Houdini is weird, it's rotated at 90-degree angle, so we want to change this angle. How you do that? Image setting, go to here and then rotate it 90 degrees so that you are aligned on the positive angle here. And then after that, we're going to do we're going to just have a transform node here. Transform node here, just for your convenience, in case you want to change the size of these images, because right now it's still quite big. So we're going to change this to a 0.25, 0.25, 0.25. Alternatively, you can just change your uniform scale. It doesn't matter. And now we're at the now we're at the next step here. What this does is that it kind of, let's say, collects some information from your image, and then you can manipulate it inside of this attribute box. So you connect this node, and here, like now, this is a much smaller scale. The reason why I actually wanted to scale it down is because of the resolution of the image, actually. But once you have this, you can double click this. And now you have a geometry global and then geometry output. So what you want to do is there is like a lot of information here. But what we need for the our purposes is we only need this P and CD. This CD is the color value. But then this is in vectorized format. So as I was talking to Lara, we always have a RGB value, right? And then each pixels here has a unique value. And then we are actually trying to harvest that color information into the Houdini. And how do you do that? You can make vector tuple, because this is you see this color? This green color is referring to the vector. And then like if you recall the high school or middle school class, vector has a direction. Like if it's just a two-dimensional vector, if you have, let's say, like a 2 here, 1 here, or this is more of a 1 and 1 here, your vector is a 1, 1, right? So this is some sort of like a, it has some sort of a connotation with a dimensionality. But we actually don't need that dimensionality. We just want to harvest this value in the 3D space. Like this is a RGB, and let's say this particular pixel is somewhere around here. We don't care about the actual location of that vector. We only care about the color value. So you know what the float is? Float is similar to the integer, but then the only difference is that this is 1, 2, 3, 4, or more of a 0, 1, 2, 3, 4, and then this is it could be this, it could be like this number. So float is something in between. It includes something in between your int value, right? And here, for our purposes, we're going to use the float. And then this function called the vector vec2float is the thing that can actually dismantle the vector to float. So once you dismantle that, you can actually have that vector information as a broken down, a pure numeric information. Once that is a numeric information, we can use that for other purposes. So in this case, because we want a 3D tessellation, what is a 3D tessellation? This is a 2D surface. It doesn't have any Z dimension. We're trying to give it a Z dimension based on the color. So we're trying to analyze the depth of it by the color difference. This is a light color, this is a darker color. That naturally means that this is, if we are understanding the nature correctly, the darker area is actually deeper in the geometry most of the time. So what we're trying to do is that to give the higher number of or higher height for the bright color, and then the lower height for the dark color, right? So that you can tessellate it in. If I draw it in section, it will be like this, right? This is the line, this is the line, this is the line. It would look like this. So we want to make that happen. And let's see how much the Houdini can actually capture of this articulation. To do that, we need to type displacement. Displacement along normal. This we're using the to assign this displacement. If this is an all information array, you need to actually assign certain direction, right? You can displace this way, display that way, display like this way. If you don't assign it, computer doesn't know. So we're actually using this plane. If I draw it in axon, this is a plane, and then this is a normal value. How do you get this normal? You use actually vector of this geometry to the cross vector calculation, and then calculate the normal vector. But Houdini is nice so that they have everything all in as a function. So we connect this to the amount, and we use this displace P to the P. But for now, nothing happens, but because we didn't connect this P information to the displacement. And I said that this already has a normal information. So what you need for that normal is a display N to be connected to the N. Then our job is done here. Let's look at that. Did you guys see that there was some sort of a bump here? It's always a hassle to navigate in Houdini. But yeah, now we have some tessellation. It catches some brick, and it catches some details here, and it catches that the location of the window is not perfect because, of course, the image was not taken in the orthographic way. It was taken in the perspective way, so that there is some sort of weird inset here. But that's okay.
Sang-Young?
Yeah.
So I followed the last part, but could you go back to the node from the attribute from map? Which are the values there? Because I'm not seeing the image yet.
Okay. So did you actually load your image inside here?
Yes.
Uh-huh.
So what else do I have to put there?
No, actually nothing. Can you share your screen?
So I'm here.
Uh-huh.
So that's the image.
Can you click this for me? Can
Which
you
one?
click this button here? I'm down here. Click this button.
Oh,
Yay. Yeah.
what happened? What's that?
That's a view. Like view, that's for the viewport.
Oh,
So
okay.
so whenever you make a new node, you can actually decide if you want to see that in the viewport or not.
I see. Okay.
Yeah.
Okay, makes sense. Thank you.
Cool. Hey, Jechang, did you get the Houdini to work for the grid?
Actually, can I show my screen real quick?
Yeah.
Okay. I don't want to be that guy, but so I don't know here. So I change. I mean, this is kind of basic setting here, and once I change that, this kind of setting here, now that shows kind of this
Shaded.
purple,
Yeah.
like that.
Just
So
go.
I'm
Just
not
change it to the flat shaded.
which one?
Flat shaded or the smooth wire shade or smooth shade. Smooth shade. Go to the smooth shade. Just to shade it. A smooth shade. Yes.
It shows nothing.
Because we don't have any geometry yet.
Okay.
Wait. Can you go to the smooth wide shaded view? Smooth wire
Smooth
shaded.
wire shape. Okay.
Yeah. Okay, it doesn't catch anything. That's strange. Why?
Right.
Can you actually give me a control of your computer?
Sure. Can I? Okay. So how can I do that? Maybe.
On the view option, I think there is a. No.
So here.
Maybe not. Yeah, I mean, just let me. So here, why don't you connect this to the subnetwork? So let's see what happens.
Okay.
Yeah.
What can I make here?
Subnet. Type subnet.
A subnet here. Okay.
Don't worry about the naming convention right now. Just connect.
Okay.
Yeah, and then go inside. Double click. Yeah. Okay, it is showing something here, but then I don't know why it's in that purple. But for now, let's catch up. Okay, delete this.
Okay.
Delete this, and then the add the node here. That is a null. Null. N-U-L-L. Yeah, null.
Yeah.
Yep. Connected.
This one.
Yeah, connected. And then the make the attribute from map.
Where is the attribute? Here.
Just type attribute from map.
.net.
From map.
Gotcha.
Yeah. Connected here.
This one to
No. Here. Yeah, connected here.
Oh, okay. Here.
Yeah. Over there.
Okay.
And click this. Click this.
This one.
Yeah. Click this. Yeah.
Okay.
Okay. And here, let's load your image.
Okay. Maybe reload.
You can click here. Yeah. Yeah.
Nothing happened. Maybe this.
Yeah.
This one?
Yeah. Just load whatever image that you want to use, you know?
Okay. Oh, shit. Okay, maybe. Okay, just this one here.
Okay, yeah.
Now,
it doesn't show you any changes.
Anything.
That's weird. That's just weird. Okay, yeah. At this point, I don't think that the I can troubleshoot right now.
Maybe I can.
I can Zoom you after our official workshop is done.
Yeah, right, yeah.
Okay.
I think that might be better. Okay, yeah. Thank you.
Sounds good. Yeah. Okay, so we're back. Let's do this. So we have this, but then there is maybe this is not enough to create the three-dimensionality. So what you could do is that multiply the amount, right? Multiply, and also you can set a constant, which is as a preset is a float. You can change your oh no, not contour. Constant here. So we can make this as like 5 times more than how it is, and then connect this here, and then connect it over there. You see, like this is much more exaggerated. Maybe 5 is too much, so let's go back to 3. Maybe 2. You have to play this. You have to play with this. I will go for 3 for now. Yeah.
There's actually a scale node on the displacement, so you don't have to. I don't know.
Yeah. Okay. Thank you. But you know, if let's say for the displacement there's a scale, but then let's say for other stuff, if that doesn't have a scale, this is a more of a, let's say, a primitive kind of a way to do it, but you can always manipulate this by multiply. Okay, so because this is some color value here, and then this is a constant, and when you multiply that, you like intensify that effect. Okay, so for now, just yeah, that looks okay. So our image tessellation is done, but it's not voxelized yet, is it? Right. So we're going to change it. We're going to do this with the another subnet here. So by the way, the method that I'm using here is actually used for the landscape generation based on the satellite image and all that. But I'm just like, you know, hacking that method to make the facade. So if you have some sort of a nice Google Earth capture, high resolution capture, you can actually make the landscape using this method. And here we do the same. We do the same thing here. We bring the node, connect it here. Now we have it. Now we have it here. Okay, we now have it here, and what we want to do is that prep this the image to be voxelized. Okay, so how do you do that? We want to make sure that everything's on the center. How do you make the something to the center? We are going to define the center of the geometry by typing in something here. So something very nice about the Houdini is that you can actually put some like very simple code within all these like tabs. So what I'm going to do here is that we are going to define the center of the this geometry. The CX is the shortcut for short for the center. So now we have this, which is a negative $ CX. Yeah, and I'm just going to copy this and then paste it on all these nodes, so that it is already centered, but then on some cases it's not going to be on your center. What did I do? Yeah, but why did I lose my control? I don't understand. Okay, good. Yeah, let's keep going and then name this as a center geo. Like we make this a geometry center, and I forgot to name this, but we can say in geo. And another nice feature in the Houdini is that you can make a switch here, and you can decide either if you want to turn it on or turn it off. One is turn it on, so we are going to turn this on. Center geo is turned on, right? And then another important thing about this application is that we want to make sure that there is some sort of a let's say virtual floor. So we're going to make a floor.
Sorry, one second. Could you go back to center geo just 1 second?
Yeah.
To see what's there? So okay, it's CEX.
Yeah.
3 values and what else? That's it.
That's it. Yeah.
That's
We're
it.
just centering it. Yeah.
Okay.
Mm-hmm. And we're going to do another transform. Over here, and then name it as a floor. How do you define? So we have to now define where is the lowest point of this tessellated image. How do you do that? We use a kind of similar method as we did on the center geo. We are going to manipulate it over here. This translate means that whatever the command that you have it here is going to override the current condition of the geometry. So what we're gonna hear is that we are gonna make a bounding box. Like in Rhino, there is a bounding box, and then but what bounding box does is that there is a geometry, and then you're going to basically cover it up like a gift. So we're going to make this like a gift box. And how do you do that? You use a BBOX. That is a short for the bounding box. And we make the bounding box, and then we now have to indicate the directory of that thing. Before we do that, actually, why not make this a switch? Why not give this switch a name? So this switch name should be switch center geo. Switch center geo, and we can actually copy this name, and for the directory purposes, you can actually do this, and then it actually brings you to these options, right? And once you type this in, this means that you're indicating that oh, I need some directory. So what we're gonna use is this as a reference. So we're changing this with this transform. Okay. So here, if I finish, you have to close this and do the colon here, and another one is that the dy min is that the minimum y point of this geometry that you have. Okay. So if you do that, it knows that it knows what's the minimum point of a y-axis.
Was it d dash what?
D underscore y min.
Okay.
Actually, I need to close this with the forward bracket. Yeah. This.
Min as minimum?
Yeah.
Okay. Okay. Thank you.
You got it? Okay. And we're going to make another switch. Switch and connect this, and are going to turn it on, of course. And now we need to extrude this. Give it a little bit of thickness. Here, I'm going to just use 0.1, no, 0.1. What was that? 0.1, and the 0.1 and facelift 0.1 maybe. Okay, yeah. Then this is going to be the end of this geometry. You can see that this is a kind of clipping the bottom out so that we can have this at the window. If you increase this depth, you can clip out a little bit more, right? Like this. But now, like some of the geometry here is submerged, so we want to go back to the this one, go inside, and then scale this a little bit more. I'm going to do 5, okay? And go back here and then see if you're missing any geometry. It looks like you're still missing some geometry, so go back here and to maybe 7. It's going to make it better, hopefully. Yeah, now we're catching most of the geometry. So for now, let's say I'm happy with this result. You can fine tune it on your own, okay? And let's define these functions, okay?
You were changing the multiplier, right?
Yeah, multiplier, yeah.
Okay, okay.
What do I want for this one? What should we call this? We're calling this displacement. Yep. And we're calling this texture apply. And we're going to call this scale down, or more of a scale manipulation. And clarity, I'm going to capitalize this. And this is a pre-voxel size. We're getting it. You know, it's a prep, right? Prep for the voxelization. Now we can go to the actual voxelization, which is the most exciting. We make another subnet, connect it, and call this. Just delete the output and connect it to another new. And what we want to do is this process could be a little bit heavy. Point from volume. What it does is that it's collecting points from the vertices that you currently have. And this here, it could be modified to get like various results. This value ideally should match with your the grid dimension. How we set up was that the size, one size is one row, right? It's a 1-to-1 relationship. But you could also set up your size as a 128, but then you can have like a 256 the rows, and then the 256 column as well. If that is the case, you would have 2 columns and 2 rows per one size unit. Yeah. So keep in mind that that should be your let's say unit convention. This your point is, let's say, separated by 0.1. that's probably way too heavy. So I'm going to change it to 1. And you can also change this ISO value. You would see later on like how this is changing. And you can also create some irregularity by introducing some jitter, okay? Now we have this. And to make as a like a voxel, what do you need? You need a box. Box. This is a primitive geometry node that is already preset in the Houdini. So we have this box, yeah, and there you can actually connect this to transform here, connected, and you can actually have a Houdini to transform these boxes according to your the point locations and size and all that. How do you do that? It's actually you can write something on the scale here. How you do it is that the CH means that you're connecting this this with something, right? And you are indicating the location of it to I mean you're indicating the directory. So directory would be the points from volume 1. Yeah, you've already, you know, gives you this option to click it. How did it disappear? Yeah, okay. Now I just typed it in as a thing. Then here you have this particle size, right? Particle separation. Under this node, under this node, a point from the volume 1, there is the point separation. No, what's the spelling? Point sep. This should be point sep. Point sep. No, particle sep. Yeah. Here, particle sep. Particle sep, and then close your bracket and close. Yeah. So now your scale is connected to the your point size. So if your point size is 1, this box will be scaled to 1. Okay. And now we want to connect these two into one thing. How do you do that? We are going to do this copy to point function. And something is wrong. Okay, yeah, don't put the / black bracket or / before the bracket. Let's fix that. I think that I used that in the lower. Okay. To save this, just for now. Okay. Okay. So now you see that there is some sort of oscillation from this geometry to this geometry. You see some reminiscence of that volume or the point cloud to become this voxelized image. And you can actually change a bunch of things here. So you can change, let's say, ISO value to -1, then it will, let's say, this is basically a threshold for the for your or how much it's going to pick up and how much is going to get filled. You see how it's As it decreases and increases, it changes its cycle volume. So using this, we can have a multiple layers of multiple layers of articulation. For instance, you can use this and you can use this at the same time to create more of a multiple layers of informations to be rendered as a, let's say, multiple layer of a geometry. But for now, we're going to just put it on -0.25, and is everyone here yet? Any problems? Any issues? No? Okay, I'll keep going then. And because this is a useful information to harvest, I'm just going to connect this to another null, and then say this is a read. And once you have this, this is still separated boxes. So how do you combine that, right? You first have to change this to VDV. VDV is some Houdini specific node or more of a file type or data type that you can process your geometry into some sort of file format. And VDV from Polygon, it helps you make this as a polygon. And you can also do something like VDV smooth. So do you see how it, from here, it became a VDV. Visually, nothing changes. But then if you make it as a polygon, all the things are kind of come together to become this one thing. And when you do VDV smooth, you can actually make it as a smooth geometry. This is not completely necessary. If you want smooth geometry, you can have it smooth geometry. Okay? So I'll just make a separate node here. VDV resample. VDV resample, what it does is that it's resampling your geometry from what's already existing. So sometimes you can manipulate your like the file size and things like that with the resample. And we're going to connect this to the VDV smooth as well, in case you want it. And we're going to create two different rules. One is here. This is yeah. So we now finished the voxelization in Houdini. So what you can do here is that you can actually save this geometry by right-clicking your boxes here. Geometry. The preset is VGO. It's not useful for any sort of any purposes. So we're going to first indicate where we're going to save this. And we're going to define the our type of extension. And here, let's say test one, and let's save it on the I'm just going to save it on the desktop because I'm going to delete that later. And that's the issue. Why did it say issue?
What was the file type? Ah, OBJ.
OBJ, yeah. Okay, I got the OBJ here, right? And we're gonna leave the Houdini for now, and then open the Blender. Before we move into that, is there any question about what we covered at Houdini so far?
Can you share this file later? I'm not sure if I like have everything in.
Yeah, sure. Yeah, I'll share this.
Okay, thank you.
Yeah.
So right now it's looking kind of very low res, right? Very like blobby. How do we? I mean, is this mesh fine, or do we want more resolution to it?
You probably want more resolution than this.
And that's controlled in the first node, right? Outside all of this.
Yeah, like if you go to here, this is at 128, but you probably want to go up to, I don't know, like 1024 if you really want a high resolution mesh.
Okay.
Right, but you know, I probably cannot use a zoom or anything while I do that. So
okay,
I didn't want to compromise. But let's test a few things out here. So we have the voxelizer here, but you can actually have a multiple voxelizer connected here. And the purpose of this is to make the multiple layers. Right now, when you look at this, this is this layer. And because I actually don't really like the smooth aesthetic, so I'm just going to change to rectangle for now. And here, you can actually manipulate these this point value to have a more segmentation. It's gonna take a few minutes, but like now you see there is a high detail here. So this is a more of a like a, I don't know, you can generate like different types of resolution or different levels of resolution from the same image to use certain information, certain mesh information as your 3D geometry as an articulation. Maybe this 1.1 was too small, so we can probably change it to 0.5, and then like it looks a little bit more, I don't know, a little bit more of a detail, but then it doesn't involve too much of a brick aesthetic. So it really totally depends on you, how you want to use this, and be realistic on the how much you want how much of resolution you want. Let's say you're doing residential project, yeah, probably then you can use like a really high mesh condition. But if you're designing let's say like skyscraper, do you want like that like high detail? Because what you would probably do at the end is that render the whole building from the outside, very far away. So you don't want that much of resolution. You just need some articulation that could be seen as a irregularity. So here you can even change the ISO value a little bit smaller in this case to just catch this thing. It's very much of a trial and error method. Yeah. And if you want some separation between your boxes, you can also, what you can do is that you can also scale this box to like 0.5, 0.5, 0.5. Then you will have this like a very tiny tile aesthetic that is not attached to each other. So one strategy that you can take is that you have this, And then you also have that the original version that we had, more of a like a chunky geometry, and then use this as a articulation purposes, and then use the other one as a more of a general kind of a massing for your facade. Okay, does that make sense?
Yeah, that's helpful. Thank you.
Cool. I'm going to save this as well, just for the fun. Okay, now I'm going to save this and then send it to the class. Okay, so it's on the chat if you want to download that. And we now go to Blender. This Blender is more suitable for the larger application. So, for example, for Carlos, if you have a larger image and use this as a the sketching tool, it should be, you know, more. It should be better to work here. So this is originally. Let me show you the original image. This is originally this image, and then using the Blender modifiers, I made this as a more or less like a porous condition with some 3D tessellation. So you can, if you zoom in, there are a lot of articulation here that happens, and then you can even make it scale up in some cases to make this a cool tessellation effect. You can later on save this individually as a STL or OBJ, and then put the texture on top to make a nice render. And this one, you can also create some sort of a 3D printable path to make the structure for your facade, so that you don't have to worry about you know, crazy detailing of insane looking facade detail. Right? Okay, let's cover this. I'm just going to delete this for now, and so for among all of you, how many people have used the Blender before? No one?
I
No
haven't.
one used Blender?
It's actually.
Okay, cool. So once you open your Blender file, delete all the camera and everything. You don't really need it for now. Light, you don't even need light, but yeah, you can keep it if you want. Just delete the cubes that you have. I'll just restart the file just to clarify everything. No. Right, like so you have this. Light and camera is fine, let them be there. And what you want to do is that here on the edge, go to mesh, and then make a plane. Okay, make a plane. Now you have this small plane here. How Blender works is that you can modify your geometry through this modifier. This small, the tool icon here, when you click here, that thing is here, but then you can add multiple modification to your current geometry. So what you want is that you want to go to the subdivision surface. What it does is,
Could you add the mesh again? How do you?
What was that? Mesh, how do you add the mesh? On the left side of the screen, there's add button.
Add, okay, mesh, plane. Okay.
Plane, yeah.
Okay.
And you go to this like a tool menu right here. and select the subdivision surface.
Subdivision surface. Okay. All right. Thanks.
Yep. And there are two kinds, Catmull-Clark and the simple. We just want to use simple one. And over here, you can actually see it as a wireframe over here on the right corner. There are multiple views here. You can change it to the wireframe. You can change the level on the viewport to, for example, like 8 and 8. And you can after you do that, your screen will actually, let's say, update, but then unless you apply, it's not really finished, right? So you have to click apply to make that change happen. And after you go to the wireframe, you can see that your surface is subdivided to many small pieces. That is useful for voxelation. Right?
Can you show it again? Where's the apply?
Where's what?
The how do I do the apply?
Apply. So you go to here, and there's this small arrow next to the camera icon. Apply. Or you can just do Control A as a shortcut.
Oh, okay. Thank you.
Yeah. Now is everyone here?
Yes.
Okay. Now, like with this plane selected, we can add another modifier, which is called displace. So click this displace, and what you can do here is that using a certain type of image, you can make a displacement. It's the same theory as the Houdini one. Now I just did, by clicking the plus button here, I made a texture. And once I made this texture, you can go to the texture here, which is this button. So if from here, I went to here. This is a texture icon, right? And I'm going to, for now, I'm just going to demonstration purposes. There are some presets here that you can do the tessellation here. This is by what is it? Like a Musgrave. You can do some noise. You can do like marble. So you can actually create more of a microscopic kind of a landscape of how marble is, so on. But for our purposes, we are not going to do that. We're going to use image. And here, image or movie, you select this button, and you can now upload your own file. Okay. And what I'm going to use for this purpose is a little bit of a bigger image. See now, like, do you see this image as a texture? Now this is looking a little crazy because we didn't change the strength of it, but now we see that the tessellation is working in its own way. After you do that, to have a more of a balanced kind of a, let's say, stepping, we want to change this RGB value to linear. So this is now linear. You can like do the different types of a value. And after you apply the texture and then you see this tessellation is happening, you can go back to your modifier and then you can change the strength of it. Now this is a little bit too insane, so we're going to change to, let's say, 0.5 maybe. Is this too much? To see it better, you can go to the shaded view again, and you can now see this this crazy form that has been made. And you can maybe go even lower, maybe even lower. I'm using 0.1 now. And you can also change this mid-level to change the overall kind of a strength of it. If you want more three-dimensionality. You want to have it lower. If you want more if you want less height for your facade, you want to have it at 1. For me, I think because this is just a facade, I'm treating this as a facade panel. I'm just going to put it at 1. Okay. And once we've done this, we're going to hit apply here. Then your plane is now transformed into this displacement model. Yeah. There are more things that you can do. If you go to, there are a lot of add-ons that you can add to the Blender. If you go to the edit on the left screen, you can go to the preference. And on the preference, you can search many different things. I'm going to type mesh. What was it called? Skin. Tissue. Yeah. Mesh tissue, or just type tissue. Yeah, here, I checked this on the add-on. Right? You probably have it unchecked. So check this, install. Oh no, actually don't install because it's already within the Blender the package. You just have to activate it. So by checking this box, you're activating it, right? And then you click refresh, then this mesh tissue is already on. And close that, select this, and if you click this a small arrow right here, you have this small tabs here. Item is to change the general, like a geometrical information about your mesh, which is location, rotation, and scale and dimensions. We don't need to change anything for now on this view. And here you can either do dual mesh or the tessellate. But before we go to that, we're going to actually use another modifier, because right now this is a way too spiky. We don't want something too spiky in our geometry, because that's not good. What we can do is you select remesh. Where are you, remesh? Remesh. You select remesh, and once you click that, it's trying to process your geometry. And the preset is a voxel, but you want to click the blocks right here. And right now your oak tree depth is 4, but if you increase it to some value like 8, now it picks up more over your geometry within this, thing. So based on the, just like how we change the ISO value to ISO value and then the scale of the boxes to create different types of let's say articulation condition. This is the same. You can change this value to like 9, then it will pick up even more things. And you can also play with the scale, and then it will change the size of the boxes to make this geometry. So when you look at here, this is now becoming highly articulated surface. I kind of like this one, actually. You just have to test things out. Oh, I like that one too. Yeah, I'm gonna go with this, actually. So if I like this one, just, you know what? Before I do that, I'm just going to delete this and make a copy of this one so that I don't have to worry about coming back to it. So I have a copy of this plane over there. That's a duplication. The shortcut for the duplication in the Blender is a Shift D, and then you can move it to the another location.
Should we apply first, or?
No, don't apply first, because I want to at least have a 2 or 3 selections so that I can decide later which one looks the best.
Okay.
Yeah.
What was the shortcut again?
Control Shift D.
Oh, Shift D. Okay.
Yeah. Is everyone here? Did you guys catch up so far to this point? Okay, good. Let's proceed. I'm going to add remesh again here, and this is in box zone, but we want blocks. You can also do smooth, but you know, it's basically based on what you want. If you want smooth geometry, if you like smooth geometry, you can do smooth geometry. No one's gonna stop you. Like, this is a more of a smooth version, where it's like more blobby. But if you like more of a rectangular things like me, you want to go to the blocks. But anyway, let's have that, and that looks pretty cool. So I'm going to actually apply this condition. And by the way, like you remember when we add the meshes here, when we add the meshes here, we first command that we use was the subdivide, right? Based on the number that you put it here, your resolution of a final outcome will be decided, right? So if you have a more division, that means that you're gonna have a higher resolution. If you want to have a less division, then you're gonna have a low resolution for your extrusion. You don't always want the high resolution. Sometimes you want to play with the low resolution. It depends on the size of your original image, right? So be smart on using this as a guideline for your resolution. Okay, so we have this now. Then now we can actually go use this tissue tool. Were you guys successful on the activating the tissue add-on? Are you guys all here? Tissue tool?
Yes.
Okay.
Yeah.
Now we have 2 options, a dual mesh. We're gonna do the dual mesh first. It's computationally a little bit heavy, so it's gonna take a few minutes. What this does is that it's more or less make your mesh cleaner, so that you can use that as a some sort of a baseline to make more tessellation, articulation, and all that kind of stuff. You know, like in the complicated meshes, like if this is the thing, you would have a different types of like a mesh density like this. But what the dual mesh does is that it's going to more or less make it kind of evenly divided, so that whenever you apply like tessellation on your each mesh basis, it's going to even that effect overall. Okay. Hopefully it doesn't crash. Just wait a couple minutes. I'm going to actually stop sharing screen for now because I think that my computer is having some problem with the memory or something. So let's see how my computer is. It's actually fine. How's yours running?
Same.
Same thing. Let's try this again. I'm just going to close this and then make much smaller grid for the demonstration purposes. Let me quickly redo this. I'm just going to speed it through. Okay, so. Maybe that was too small. Yeah, that's actually way too small. A little bit bigger and smaller. Okay, I think that's a little better than before. And actually, we don't need to increase the Z direction. Now we're ready to run the displacement. We'll open. Okay. Now something's happening here. See that. Use that. Maybe it's still like, very low res. Maybe it's too low res.
I think I got it.
You got it? Okay. Nice. I'm just going to be happy with this right now, and keep proceeding to the next.
Can you sort of elaborate again what does this do mesh doing? Because I don't really understand the result.
Okay, so before doing that remesh, it's all just one surfaces with the little bit of the coordinates like poking out and in, right?
Yeah.
Like for example, this is extrusion. It looks like extrusion, but it's not really extrusion. It's more of a there's a vertex, 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 and it's connected as like this This is more of a still two-dimensional. It's in the two-dimensional realm. Because this is, at the end, this is still one plane that is just poking out like this, right?
Yeah.
But once you do the remesh, it actually voxelized that mesh into more of a three-dimensional space. Do you see how this is closed out?
Mm-hmm.
So that you can use this for your, you can use this as like a facade or any sort of, baseline to process your geometry.
It works like the VDB in Houdini.
Yeah. No, like it's actually in the Houdini. If I explain it through the Houdini, do you see this point? This is still in the realm of the point. Like this is a surface, right? This is a surface that is like a stretched out, and then now on Houdini they're collecting points based on the highest point of that stretched images as a vertices. And then you place the box, these small boxes all over the places on top of that image. So that now this is a three-dimensional information rather than two-dimensional information. We're now at this point.
Correct.
So what that remesh is doing is from here to go here. Okay. So yeah, so we have that remesh, and we're gonna apply. I'm not gonna be too picky about the shape that I'm gonna end up having. So that's processed, and now we're gonna do create. Go to create, or yeah, edit on the edit. We're gonna do deer mesh. Let's use our time more efficiently. Because now we have to wait for this anyway, we're going to take a 10-minute break and then come back to it later. Is that fine with everybody?
Yeah, actually, so
Yeah,
mine has been thinking, up until now, I don't know if it will crash or not, but maybe you could share the new file that you have done here so we can use.
Okay, yeah, sounds good. So see you guys in at 6:20. Yeah.
Sounds good.
Yeah. See you.
Thank you.